Hello, everyone. So today we're going to go through the next section of chapter 5. I know we went a little out of order. We jumped to 5.4, but the reason for that is because we were just focusing on triangles. So classifying triangles, angles of triangles. We had exterior angle, base angles theorems, um, equilateral isosceles, everything about triangles. So for this section and then the rest of the chapter, we're going to focus on this idea of congruence now. So 5.2 is going to deal with congruent polygons. And as you can tell by the chapter title, uh, we'll talk about all polygons today, but the rest of this chapter is going to focus on just proving triangles congruent. So we're going to focus on triangles. But let's talk about this idea of congruence first. So we say two polygons are congruent when all of their corresponding sides and all of their corresponding angles are congruent. Okay, so that means um, whatever shape I have, whether it's a pentagon or an octagon, every single corresponding side is congruent and every single corresponding angle is congruent, which means, and we know this from when we were doing rigid motions back in the last chapter, that if all the sides are the same and all the angles are the same, they're going to have the same size and the same shape. So if I look at triangles here, it could be, once again, any polygon, but um, I could see all my markings here. Like we have the single arc, so this angle corresponds to this angle, and we have all three angles and we have all three sides. So all three corresponding sides and all three corresponding angles are congruent. So we can say that these two triangles, and just visually, it looks like a reflection here. If I just flip it over, red would flip over to red, blue onto blue. They would be the same shape and the same size. So what we're going to do is very important is we're going to write a congruent statement. So when we state that two shapes are congruent, we have to be very careful about the order of the letters. And what I mean by that, and you can tell by that it's easy to see with the color here, but if angle A, the single arc, corresponds to angle D, the single arc, A and D need to be in the same position. So here we have three letters. It's a triangle, obviously, but A and D are both the first letter. So I know that A, we say, corresponds to D. So just from the statement, I know that A is congruent to D. And you could tell we also have, by the color, we also have the second letter corresponds to the second letter. So angle B corresponds to angle E. And we can see that those both have the triple arcs on them. And C corresponds to F. Those both have the two arcs on them. Okay, same thing with sides. Remember, to name a side, we need two letters. Like here, we have AB. So the first and second letter here corresponds to DE. So red blue corresponds to red blue. Those both have the double arcs. And remember AB and BA, I could switch. Usually it's just keep the same order, but BA is the same side. BA still refers to this side. Um, but the second and third letter, BC, EF, second and third letters, those are congruent. And then the first and third, AC and DF are congruent, and AC and DF we can see have the triple arcs on them. So those sides are congruent. Okay, so we don't need a diagram. So before we move on, if I just have a congruent statement, so if I know that triangle LMN is congruent to triangle PQR, we can know since we have three sides and three angles in a triangle, we from this statement we could come up with six different statements. So if I look at the sides, like if I look at LM, for example, the first and second letter, that corresponds to PQ, the first and second letter. So from this statement, I know that side LM is congruent to side PQ. We also have MN, second and third letter, so that will correspond to QR, second and third letter. So MN and MQR are congruent. And then my other combination of letters would be LN, first and third, corresponds to PR, first and third. So these would be my three sides. Obviously, it would be easier to see on a diagram, but from the statement, using the corresponding positions, we can come up with the three side congruent statements here. Okay, and then for the angles, once again, um, angle, we could just use one letter. So angle L corresponds to angle P. Those are the first letters. The middle letters are M and Q, and then the third letter N and R. So these would be the three angles. I'm not going to write three angles. Sorry, I'm not the best writing with the trackpad, but these would be the six statements that we can come up with from this single congruent statements about these triangles here. Okay, so if I look at some quick multiple choice here, it says if triangle RST is congruent to triangle XYZ, which of the following need not be true? Okay, so that means three of these are true, one of them isn't. So if I go one by one here, it says angle R is congruent to angle X, so R and X are both the first letter, so this is a true statement. T is congruent to Z, so T is the third letter. Z is also the third letter, so those angles are in fact congruent, so this is also true. RT, so RT would be the first and the third letter, is congruent to XC. X is also X is the first, C is the third letter. So once again, that is a true statement. So it looks like it's going to be this last one. If I look at this one, SR. So SR here is the first and second letter is congruent to YZ, but that is the second and the third letter. So those are not in corresponding position. So answer choice D will be my answer for that one. Okay, if I look at number two here, ABC is congruent to DEF. Okay, so it tells me the measure of A is 50 degrees, so A is going to be 50 degrees. Measure of E is 30 degrees. Okay, and what is the measure of C? So we're looking for angle C here. Okay, so I know I have my triangle sum theorem, so I know all three angles on my triangle have to add to 180. So I know A is 50 degrees. B is the second letter, so that corresponds to the second letter here, E. So if E is 30 degrees, that's congruent angle B, so this would also be 30 degrees. Okay, so we have all three angles here. So all of these three angles would have to add to 180. So 50 plus 30 would give me 80 degrees. Okay, so to have 180 in my triangle, from 80, I need 100 more to get to 180. So that means both angle C, the third letter, and angle F, the third letter, would both have to be 100. So answer choice C. Okay, so it gave me an angle in each triangle, but if A is 50 degrees, that means D is 50 degrees. So all the corresponding angles are congruent according to this statement. Okay, so let's look at some algebra type questions here. So if I look, so now we have a quadrilateral here. So four sides, so not a triangle, but it tells me that DEFG is congruent to SPQR. So these two quadrilaterals are congruent, which means all the corresponding sides, all the corresponding angles are congruent. Okay, so the first thing it asked me, it says find the value of X. Okay, so if I look at my diagram, I'm gonna not use the pen here. I'm just gonna X out here. So let me pull up a different scratch pad here. Okay, so it says find the value of X here. Okay, so the first thing I notice, hold on one second, I'm sorry. Okay, I'm just gonna not write it. Okay, so if I look at where X is, so I see X, there's an X right here. So this would correspond to angle Q. Okay, so if I look at angle Q, that's the third letter in this quadrilateral. Okay, so I know that would be congruent to the third letter in this quadrilateral, which is F. And if I look D, E, F, these aren't in the same orientation. You can see it's one's rotated. So I can't just go by the diagram, like say these are both 102 in the top left because I have to use, they're not in the same positions. I have to use my statement. So F and Q are congruent. So that means if I look at F, that's this angle here. Okay, so that means this angle would also have to be 68 degrees. So I could write an equation here. So I know that 6y plus x would have to be equal to 68 degrees. But unfortunately, as you can see, we have two variables, y and x. So I can't really solve this for x because I would just have 68 minus 6y if I bring that over. So that's not really going to help me. So if I look at where else an x is, there's an x here as well. Okay, so this side is QR. So QR is equal to 2x minus 4 feet. So in my statement, QR is the third and the fourth letter. Okay, so that will correspond to FG, the third and the fourth letter in this one. Okay, and if I look at FG, FG is here. Okay, so that means this 2x minus 4 would have to be equal to 12 feet. Okay, so I could also make that make. So 2x minus 4 would have to be equal to 12. Okay, and this one I can solve. So to solve this one, I could simply add 4 to both sides. So 2x is equal to 16. And if I divide both sides by 2, x would be equal to 8. Okay, notice it just asked me for x. So this is part A. So I don't need to plug it in. If I did plug it in, 2 times 8 is 16 minus 4 is 12. So we already knew it was 12. So plugging it back in, we could check our answer, but we already knew it had to be 12. Okay, so there's part A. And now that we know x is 8, now I can substitute in. So 6y plus, I know x is 8 here. So if I do that, now we are able to do part B and find y. So for part B, to solve for y, I could minus 8 on both sides. So I know 6y is equal to 60. And if I divide by 6, y would be equal to 10. Okay, sorry, let's go down here. So let me build some. So y would be equal to 10. So that's part B. So I want to do the side first, but usually if this was just one letter, we could doesn't really matter which one we do first, but I needed to find x first in order to find y. Okay, let's look at another example here. Let me get rid of my markings. All right, so in the diagram, it tells me LMN is congruent to WXY, so LMN WXY. So once again, they're not in the same orientation, so the congruent statement is going to be important. Okay, so the first thing it tells me is to find WX. So if I look at my congruent statement, WX is the first and the second letter. So that side is congruent to LM. So my diagram, what I'm going to do, and hopefully you wrote down the diagram as well. So LM, I'm going to put a tick mark there. So LM is congruent to WX. So these two sides are congruent. So that means if LM is 12, WX would also have to be 12. So my answer for the first one is going to be 12. Okay, next thing it asked me is for measure of angle L. So L is the first letter, so angle L is going to correspond, so if I put an arc here, to angle W, the first letter here, angle W. Okay, and we can see W is 44 degrees, so that means I could label this one as 44 degrees as well. So that'll be my answer for that one. So 44 degrees. Fix that. Okay, and the last one it asked me is for the measure of angle Y. Okay, so Y is here. So well, if I knew both of these angles, I could just make sure the triangle adds to 180. So if I know this is 44, if I look at angle X here, and my X is the second letter, so that's going to correspond to M here. So M and X are both congruent. So I put two arcs here, I could put two arcs here. Okay, so that means if M is 71, the second letter X would also have to be 71 degrees. Okay, which means whatever Y is, it would have to get me to 180. So what I can do is I could do 180 minus these two angles and see how much more I need to get to 180. Okay, so if I pull on my calculator here, I can do 180 minus the 71 minus the 44. Okay, so it looks like we have 65. So that means this angle would also have to be 65. So if I have 71 and 44, the missing angle would have to be 65. So those are both going to be 65 degrees. Okay, I want to look at one final example. So here we have a wall. So it says you divide a wall into orange and blue sections. So the left is orange, the right is blue, along JK. So JK is what's splitting it. Will the sections of the wall be the same shape and size? Okay, so remember, if the same shape and same size, that means it's asking, are they congruent? So in order to be congruent, or in order to have the same size, all the sides need to be the same. And in order to have the same shape, all the angles need to be the same. So if I focus on the sides first, um, we do have a tick mark here. So we have the bottom sides congruent, and it's a four-sided figure, right? One, two, three, four. So these are quadrilaterals here. So we have one tick mark, we have two tick marks. So we have two sides congruent. We have three tick marks. So three sides are congruent. So the other side of my four would be this side here, JK. And notice JK is a part of the blue and a part of the orange quadrilateral. So JK is a shared side. So since JK is in both, what I can do, and what I mean by the X, we're going to be doing that more often later on, but I know that JK is congruent to itself, right? So if you think about what property this is, it's been a little bit saying something is congruent to itself. That's the reflexive property of congruence. So we can use the reflexive property to get our fourth side. So we have these three sides and then JK and these three sides and JK. So we do have all four sides congruent. So that means it is the same size. So we have all four sides congruent. Okay, and if I look at the angles, let me go ahead and get rid of my markings here. We have the right angles. We have two right angles here and here. So one, two, one, two. So we have two angles here. Okay, so the other angles, we don't have markings. They're just labeled one, two, three, and four. But what you'll notice is since these are right angles, what I can conclude is that the top and the bottom sides are parallel, right? Because 90 and 90 is 180. So if I have my consecutive interior, remember the consecutive interiors make the C on the inside. So if I have my consecutive interior angles adding to 180, they're supplementary. The top and the bottom would be parallel. Okay, so if the top and the bottom are parallel, JK is a transversal, which means we can prove that angle 1 and angle 4 are what type of angles? So think about that for a moment. Angle 1 and 4 would be what type of angles? So you should have said they're alternate interior, right? So I could say that 1 is congruent to 4. And the reason being is they're alternate interior angles. Okay, and the same thing with 2 and 3. They're on the inside and they're on left and right opposite sides. So 2 and 3 are also alternate interior. Okay, so you have one, two, three, four. So we do have all four angles congruent, which means it is the same shape. So our answer would be yes. And our explanation would be all four sides are congruent. We use the reflexive property for the shared one in the middle, and all four angles are congruent. The two right angles, and then we have two pairs of alternate interior angles. So one, two, three, four. So all four angles are congruent. Okay, so what I want you to do is pause the video and I want you to try these two problems on your own. So the 4x minus 5 is a little hard to see. That refers to this angle here if it's hard to tell. Um, but see if you could find the value of x for number 4 and see if you could find the answer for number 5 as well. Okay, so hopefully you tried it. So let's go ahead through the work here. So, um, okay, so it asks for x, which is here. So this corresponds to angle h, which is the fourth letter. Okay, so that would correspond to angle F. So I want to set that 4x minus 5 equal to angle F, which F is here, so F would be 105. So you should have set 4x minus 5 equal to 105 and gotten 27.5. So that should be your work for that one. Okay, and for the bottom one, remember, if I want congruent, we need to show all three sides are congruent, all three angles are congruent. So we do have all three sides marked 1, 2, 3, 1, 2, 3. So we have all three sides congruent. And if I look at the angles, well, first off, we do have vertical angles here, right? So we have angle T is sort of shared. So these are vertical angles. So that's one pair of corresponding angles. And what you should notice is we do have parallel lines as well. Okay, so if I focus on just these lines being parallel, highlighted in green, we have two transversals. We have two lines that hit both of the green ones. So if I focus on one of the transversals, either one, once again, you should notice similar to the last one, we do have alternate interior angles. Might be easier to visualize without the triangles, but you can clearly see now that these are in fact alternate interior, right? They're on the inside of the lines, one's at the bottom, one's at the top. So we do have alternate interior angles. And I could also look at the bottom transversal here, or this one. So these would also be alternate interior angles, if you're able to visualize that. So they're on the inside, on opposite sides, if I consider this my transversal. And once again, I have the vertical angles. I think the main thing I want to focus on is when you're labeling the angles, make sure to differentiate. So if I already have this one labeled as a single arc, don't label the vertical angles as a single arc. I'll do a triple arc because I already have the one. So three arcs would correspond to three arcs here. So we have all three sides and all three angles. So yes, our answer is these are in fact congruent triangles. Okay, so to finish up this section, I'm going to go through one theorem and then we'll practice with that theorem. So this theorem has to do with the third angle of a triangle. So if you think about it, I want you to just think about this for a moment. If I have two angles of a triangle congruent, what do I know must be true about the third angle? So if I have these two angles congruent, what must be true about these third angles? Um, and you probably noticed with the last example we did, like for example, like say for example, I don't know, this is 50 degrees and this is 30 degrees. We'll pick easy numbers. Um, okay, so that means if these are congruent 50, this will be 50 as well. If that's 30, single arc here would be 30. Okay, so if I have two angles, what you'll notice, well, we have 80 degrees, so we need 100 more to get to 180. So this forces this third angle to be 100, which means this angle also has to be 100. So if you have two angles in a triangle congruent, it forces that third angle must be congruent as well, because it's the same value in each to get you to 180. Okay, so this is going to be called our third angles theorem, and it should, if you pick real numbers, it should be intuitive. Whatever these two angles are, um, it just whatever gets me to 180. So if you have two angles of one triangle congruent to two angles of another triangle, the third angles, hence the name, are also congruent. Okay, so this is the name of the theorem we'll be using. So if I know A and D, the double arcs, and B and E are congruent, the single arcs, we can conclude, once again, conditional statement. So if this is true, then our conclusion is that the third angles, so C and F, also have to be congruent, right? So if A and B are together 150 degrees, that forces C, which means it forces F to be 30 degrees, whatever gets me to 180. So this is our third angles theorem. Okay, so let's look at an example with this, and then we'll also look at a proof to finish up, and that'll be it for this section. So if I look at these two triangles, once again, pause the video if you need to copy down the diagram, it's asking for the measure of BDC. Okay, so actually we have a bunch of triangles here. We have like this triangle here, we have this triangle here, we have a triangle at the bottom here. We also have sort of the big triangles here. So what I'm going to do is I'm going to focus on the big triangle there. So sometimes when our triangles are overlapping like this, it's helpful to separate the diagrams because it's asking for BDC. So BDC is this entire angle. Okay, so if I look at this angle here, this would be a part of, if I continue this triangle here, right? I don't want to make this triangle here because then I need this entire angle, so I need to continue this bottom one here. So this triangle here. Okay, so if I redraw that, I'm going to redraw it over here. Just copy exactly what I have. So this is C at the bottom left, that's D. And we have B at the top with the single arc. Notice the 30 degrees only a part of it here, so only a part of this is 30. So the entire D, that's what we're looking for. So I know a part of it is 30, but I don't know this top part here. But I do know C has the double arc, so I'm going to label that as well. Okay, if I look at single arc, we also have a single arc over here. So if I look at this triangle going this way, pardon the crudeness, we do have a 45-degree angle labeled here. That's angle A. So if I look at this triangle, we have C down here, and then we have D going across here. Okay, now this small angle, if I look at this angle here, if I pull this out, this is 30 degrees. So we do have that labeled as well, and that's a double arc there as well. Okay, so if I look at my diagrams, well, we have the single arc is 45, so this would be 45, which means 30. This would be 30 as well. So to find the question mark, what it's asking for, BCD, simply we could just take 30, 45, see how much we get to 180. But um, we could also use the third angles theorem, right? Because if I know these two angles are congruent, that means the third angles, this angle and this angle, have to be congruent as well. So if I have two angles of a triangle congruent, the third one has to be congruent as well. So I don't even need to copy the 45 and 30 over here. I can simply just find this angle here because the third angles theorem tells me. So 180 minus 45 minus 30 would get me my answer. So if I see how much more I need to get to 180, it's going to come out to be 105 degrees. So this angle would be 105 degrees. Okay, so you don't need to separate it, but if you're able to visualize it, you do have two angles. So you do know that the third angles are congruent here. Okay, let's go ahead and finish up with the proof here. I'm going to switch over. I'm not going to try to write with that pen. Okay, so the final example. So we want to prove that ACD is congruent to CAB. Okay, so if I want to prove triangles congruent, at least now, like I said, the rest of the section, well, we're going to come up with shortcuts. But by definition, we need to show all three sides and all three angles are congruent. So six different things, which obviously is tedious, six different statements, which is why shortcuts would be helpful here. So that's the rest of the section, the chapter, going to focus on that. But let's go ahead. Statements, reasons. and start writing our proof here. So we want to prove, so given, we don't have givens right now, but we do have label markings on the diagram. So those are given to us, we know. So I'm going to do one at a time. So let's do the sides first. Okay, so we need to prove that all three sides are congruent. Okay, so we do have a single tick mark here, so AD. So we know that AD, the single tick mark over here is BC. So AD is congruent to BC. And you can see here, AD is the first and third letter, BC is the first and third letter. Actually, it's switched around here, so I'll keep the same. I'll keep the order of the congruent statement. Okay, and then the double tick mark, we have DC here. So DC or CD is the second and third letter, so I'll just keep the order. So CD, and that would be congruent. So the double tick mark here is AB, the second and third letter there, so AB. So we have two sides congruent, so this is going to be given. Okay, so we need to show all three sides. We're missing the side. So if I look at what side we're missing, I have this side and this side. So my missing side would be this middle one. But once again, you should notice that if I look at the middle side for the red triangle, and I'll do the other one in purple, it's a shared side, right? So AC is in both the red and the purple one. So I can state that AC is congruent to itself, AC. And you notice AC, AC are both the first and second letter. It's a different order, but it's the same side, right? So I can state that it's congruent to itself, and that's the reflexive property, right? So reflexive property of congruence. Okay, so we have all three sides stated. Okay, we also need to show all three angles. So if I clean this up a bit, let's go ahead in our angles. So we do have a single angle here. Okay, so that's angle CAD. Okay, and that would be congruent to, we have a single arc here. So that's ACB. Okay, sorry. ACB. Okay, and we also have a double angle here. So this is angle ACD. So angle ACD is congruent. So the double arc here is BAC. Well, it doesn't matter the order letter. If I say CAB, that's the same angle. This double arc here is CAB. So either one would be fine. Doesn't matter how I name it. So that's labeled in the diagram. So once again, that's given to us. Okay, so remember, we need all three angles as well. So we have two angles, but this third angle, which here D and here B, it's not labeled. But remember, we have our third angles theorem. So if I have two angles of a triangle congruent, which we do, it forces the last angle. So I could just say angle D. It's by itself, so I could just use a single letter. And angle B would have to be congruent to each other. So that'll be our third angles theorem. Okay, remember, which makes sense, right? Because if this is 30 and this is 50, that means this is 30 and this is 50. These would both have to be 100. So if I have two angles, that third angle, those third angles have to be congruent. So we do have all three angles as well. Okay, so since I have all six pieces now, three sides, three angles, we can conclude by saying what we're trying to prove. So I'll just copy down what we're trying to prove. So triangle ACD is congruent to triangle CAB. Okay, and the reason for that is we prove that all corresponding sides and all corresponding angles, so CORs corresponding, I'm abbreviating, are congruent. So that's the definition of congruent polygons. Okay, so that's what my proof will be look like. Okay, so the assignment will be on big ideas to practice more with this section. So you should complete that. You can start it now, and if you don't finish, you can finish that for homework. All right, everyone, take care.